Okay, this is part 2 of the Chapter 9 review video. In part 1, we went through the first 11 of the review problems, so we're starting here with number 12. The directions say, solve each absolute value inequality, graph the solution set, oops, a little redundant there, graph the solution set, and write it in interval notation. And problem number 12 is the absolute value of 3x minus 2 is less than 13. So you have to remember what to do when you have the absolute value of some expression less than some number. So the rule is you take the expression and you write it between negative and positive that number. So it would be negative 13 is less than 3x minus 2 is less than 13. So notice part of that looks exactly like what we started with, but without the absolute value bars. 3x minus 2 is less than 13. But then we've also got this negative 13, and 3x minus 2 is in the middle on the big side of negative 13. Now this could also be written as three x minus 2 is less than 13, and 3x minus 2 is greater than negative 13. That really means the same thing as what I put over here. It's just another way of writing it. If this makes more sense to you, it's perfectly correct to set it up that way. I think it's easier just to put it all in one three-sided inequality like this. But this does mean that 3x minus 2 has to be both on the small side of 13 and on the big side of negative 13. It has to be between those. Okay, so from here, we have to solve this three-sided inequality so that we end up with just plain x in the middle. Right now, we've got 3x minus 2 in the middle. So first, let's undo the minus 2 by adding plus 2 to all three sides. The negative 13 plus 2 would be negative 11. Then 3x minus 2 plus 2 would just be 3x. And then 13 plus 2 would be 15. So now we've got negative 11 is less than 3x is less than 15. And to go from 3x to just x, divide by 3. And we have to do that on all three sides. So that gives us negative 11 over 3 is less than x is less than 5. Now on the number line, here's 5, of course. And then negative 11 thirds, that's the same number as if you wrote it as negative 3 2/3 or negative 3.666 repeating. So it does live between negative 3 and negative 4 on the number line. It's between negative 3, which would be negative 9 thirds, and negative 4, which would be negative 12 thirds. So the solution set is the interval from negative 11 thirds to 5. Number 13. The absolute value of 7 minus x is greater than or equal to 2. So remember how this works. The rule is when you have the absolute value of some expression greater than or equal to some particular positive number, that has to break down into two separate possibilities. So one of those is just 7 minus x is greater than or equal to 2. Or the other one is 7 minus x is less than or equal to -2. So notice how that works. The first part looks exactly like this without the absolute value bar. 7 minus x could be greater than or equal to 2. Then we have the word or, and then we have the same expression, 7 minus x, but the inequality is pointed around. It's less than or equal to -2. Notice these are going opposite directions. You can be either a really big positive number that's bigger than or equal to +2, or you can be a really negative number that is less than or equal to -2. Now we got to finish solving each piece. I want to end up with x by itself on one side, so first I will subtract 7 on both sides. That gives me -x is greater than or equal to, let's see, 2 minus 7 would be -5. Or in the other inequality, subtract 7 on both sides, we get -x is less than or equal to -9, because -2 minus 7 would be -9. Now in both of these we have a -x on one side and we want just an x. So to go from -x to x, we have to divide both sides by -1. But remember, when you have an inequality and you divide both sides of the inequality by a negative number, you have to reverse the direction of the inequality. -x divided by -1 is x. The greater than or equal to sign gets flipped around and becomes a less than or equal to sign, and the -5 divided by -1 is 5. Or, and then here, same thing, if we divide both sides by -1 and flip the direction of the inequality sign, we get x is greater than or equal to +9. So there's our solution. X is less than or equal to 5, or x is greater than or equal to 9. The numbers that are less than or equal to 5 are all the numbers from -infinity up to and including 5. The numbers that are greater than or equal to 9 are all the numbers from 9 up to infinity, and together those two separate intervals make up our solution set. And then example number 14 has the absolute value of something being greater than -9. Well, no matter what's going on here, no matter what x is, no matter what 11 minus 8x is, when you take the absolute value of that, the result is always going to be a positive number. If 11 minus 8x was positive to begin with, the absolute value is positive, so it's greater than -9. If 11 minus 8x was negative, the absolute value is positive, so that makes it greater than -9. Worst case scenario is if 11 minus 8x comes out 0, then the absolute value would be 0, but that's still greater than -9. So x can be anything, and this will always be true. The solution set is all real numbers. Now, graphing linear inequalities in two variables. So now we're looking at inequalities that have x and y both in them, and we're looking at the two-dimensional graph. So remember, when we do that kind of thing, it's a two-step process. Step 1 is to graph the line where the equation would be true. So we would be graphing the equation 4x minus 2y equals 8. One point on that line would be if x is 0, -2y would equal 8, so y would equal -4. So that line does include the point 0, -4. It also includes the point where y is 0, then 4x equals 8, so x is 2. So there's the point 2, 0. And once we have those 2 points, we can draw the line that goes through them. And I have made it a dotted line or a dashed line because this is a greater than sign. If it was a greater than or equal to sign, we would make it a solid line because then we are including the points where it's equal. But here we're not including the points where it's equal, just the points where 4x minus 2y is strictly greater than 8, so we make it a dotted line. Now to figure out which side of that line to shade, we can test a point like 0, 0. If I plug 0 in for x and 0 for y, I get 0 is greater than 8, and that's not true. So we do not want to include the side that has 0, 0. We want to be on the other side, and that's why this side of the line is shaded. Number 16. Here we would start by graphing the equation y equals 1/3 x plus 2. Now, because that is in slope-intercept form, y equals mx plus b, probably the easiest way to graph that line would be to start at the y-intercept 2, and then use the slope 1/3 to figure out where to go from there. So if you start at the point 0, 2, the y-intercept at 2, and then rise 1 and run 3, go up 1 and over 3, you get to another point on the line, and then you can just draw the line through there. This time we made it a solid line because it said y is less than or equal to 1/3 x plus 2. So to show that we're including the points where it's equal, we make it a solid line. Now, I want to shade the points that are below the line because that's where y is less than what it would be on the line. And if that's not enough for you, you can test the point 0, 0. If I put 0 in for x and 0 in for y, it says 0 is less than or equal to 2, and that is true. So we do want to be on the side of the line that includes the point I tested, 0, 0. And 17, y is greater than or equal to 5. So the line where y is equal to 5 would just be this horizontal line here, the one that just goes right straight across. All the points on this line have their y coordinate equal to 5. And I made it a solid line because we are including the points where y is equal to 5. If this just said y is greater than 5, I would have made it a dotted line. And then I want to shade everything above the line where y is greater than. Up here are the points where y is greater than 5, like y might be 10 or 7 or something like that, but not the points down here because that would be where y is less than 5. Okay, hopefully you followed all that. Really hope you worked it out for yourself and got the same answers I did, or if you didn't, that you understand why. And so I'll be in touch with you about the test.